Hello students, welcome once again. Since in the previous lectures you have already known a lot about probability. So in this video we are going to describe about the Bayes theorem. So let's start our discussion. What Bayes theorem actually does? Bayes theorem provides a mathematical rule for revising an estimate or forecast in light of experience and observation. If we have estimated prior probabilities or prior information for events that we are concerned about, and then we obtain new information about them, we often would like to have a sound method by which we can compute revised or posterior probabilities. And Bayes' theorem gives us a way to do this. Whether you love it or not, you just simply can't ignore the Bayes' theorem. So it's better for us to know about this completely. Bayes' theorem is used to update the probability for hypothesis as evidence. It involves two probabilities. The first one is the prior probability. Prior probability is the initial probability based on the present level information. And the second one is known as the posterior probability. Posterior probability is a revised probability based on the additional information. Now let's just know about the Bayes theorem when we have two events. Bayes theorem is a method of revising a probability given that additional information is obtained. If we have two number of events which are A and B, then according to the Bayes theorem, probability of A given B is equal to probability of B given A times probability of A divided by probability of B. Here, probability of A is our prior probability or prior information that we already have. And probability of B is the evidence. And probability of B given A is the likelihood term here. And finally, probability of A given B is our posterior probability that we are concerned about. Now let's just know what are these terms actually mean. In the Bayes theorem, probability of A and probability of B are the probabilities of A and B without regard to each other. Probability of A given B is a conditional probability, which means that probability of observing event A given that B is true. And finally, probability of B given A is the probability of observing event B given that A is true. Now, let's just think about the Bayes theorem by using a flowchart. At first, we have some prior probabilities or prior information. Then, we simply get some new or additional information. Then we apply the Bayes theorem, and finally we get the posterior probabilities or conclusion that we are concerned about. So far we have discussed about the Bayes theorem on mathematical sense. Now let's just think about the Bayes theorem in a different perspective. Remember, there is no mathematical sense about this. It's just simply an attempt to think Bayes theorem in a different way. We all are in a pandemic situation now. So in this situation, Netflix is a good source of entertainment. So let's just think that we have some prior probabilities of chilling, and then we have information about probability of having Netflix account. We have information about the likelihood term, that is probability of having Netflix account given that you are chilling. So by using the Bayes theorem, you can compute that what is the probability of chilling given that you have a Netflix account. So you can also think about the Bayes theorem in this way. There are so many qualities that are making Bayes theorem so cool. Bayes theorem describes what makes something evidence and how much evidence it is. Science itself follows the Bayes theorem. Science is a special case of Bayes theorem because in science, you are revising a prior probability in the light of an observation or experience that confirms your experimental evidence to develop a posterior probability, and finally you can make conclusion. It is widely applicable in computational biology, medicine, computer science, artificial intelligence, and so on. Let's discuss a simple problem based on the Bayes rule. Let's consider that we have a manufacturing firm that receives shipment of parts from two suppliers. Let A1 and A2 be two events which indicate that a part is received from supplier 1 and A2 indicate that the part is received from supplier 2. So we have two suppliers, A1 and A2. Now the company has prior information or prior probabilities that the parts that they're receiving, the probability that of having parts from supplier 1 is equal to 0.65 and probability of having parts from supplier 2 is equal to 0.35. So these are our prior probabilities. The parts that the company received are quite different. This table is giving us the information about the quality level difference between suppliers. Let G denote that a part is good and P denote the event that a part is bad. Thus, we can have the following conditional probabilities. The conditional probability that a part is good given that it has come from supplier 1 is equal to 0.98, and the probability that a part is bad given that it has come from supplier 1 is equal to 0.02. For the supplier 2, we can also have these two conditional probabilities. Let's consider a tree diagram for our two supplier example. At step 1, we have two suppliers A1 and A2. At step 2, we can have the conditional probabilities for both of these two suppliers. And finally, in step 3, we can have these four experimental outcomes. Let's just put the values of all these terms. At step 1, as we have already discussed that we have prior probabilities of parts coming from supplier 1 and supplier 2. At step 2, we can have the conditional probabilities of parts good or bad condition given that from which supplier they're coming from. And finally, we can have the probabilities of outcomes of these four events. For this problem, each of the experimental outcomes is the intersection of two events. For example, if we want to compute the probability of selecting a part from supplier 1 that is good, it simply can be computed as probability of A1 times probability of G given A1. That is, if you want to compute a part which is good and coming from supplier 1 is equal to probability of parts coming from supplier 1 times probability of a part good given that it has come from supplier 1. So if you want to know that if you have a bad bird or a broken bird, how can you find the probability that that bad bird has come from which supplier? We already know from the law of conditional probability that probability of A1 given B is equal to probability of A1 and B divided by probability of B. Let's just denote this equation as equation number 1.1. And from the probability tree, we have observed that probability of A1 and B is equal to probability of A1 times probability of B given A1. We just denote this equation as equation number 1.2. So finally, we can compute what is the probability of having a bad bird. It's just the addition of these two probabilities. So finally, we can write this first expression, which is equal to probability of having bad bird is equal to probability of having bad bird, and it's coming from supplier 1 plus probability of having bad bird, which is coming from supplier 2. And then we simply use the expression that we have discussed in the previous video, that is the expression of product rule. And finally, we can write probability of B is equal to this line. And we denote this equation as equation number 1.3. Now, by substituting equations 1.1 and 1.2 into 1.3, we can obtain the posterior probability of A1 given B and A2 given B by applying the Bayes theorem. Remember, this theorem is only for two events. And then we can finally compute these two posterior probabilities by simply substituting the values of these terms. And we can have the results. Now consider a more general case of Bayes theorem. If we have n number of events, then we also can apply the Bayes theorem. Let's suppose that I denote ith event from n events. So Bayes theorem states that, so in general, for n events, we can write this expression for Bayes theorem. Now let's consider a tabular approach to Bayes theorem of a two-supplier problem. At first, we have two events of supplier 1 and 2, and then we can have information or prior probabilities. And we have additional information of probability of having bad birds from which suppliers. From these two columns, we can compute column 4, which are giving us about information about joint probabilities. And finally, after applying the Bayes theorem, we can compute the posterior probabilities. This was all about the Bayes theorem. I hope when you understand how Bayes theorem actually works, you will be just happy as this child. But as I always say, for better learning, don't forget to keep practicing. Finally, practice more and more. Thank you for watching this video.